Hello everyone. I'm Orkubrat Das, and in this problem, in this video, we are going to discuss the last problem that is left to discuss from ISI 2023 UGB part, that is the fifth problem. Okay. It was not, I mean, it would look like a coloring problem, but it's more of a combinatorial problem. Okay. For that, let's discuss the problem. So let's go to the problem. Here. So the fifth problem, it has two parts. The second part is, I would say it's intuitive, but yeah, let's go through it. Once, that is, you are having a 1 cross n. So a single row having n blocks and 1 cross n rectangular plot, and there are three types of tiles: red, blue, and black. So red and blue are both 1 cross 1, but the black one is of 1 cross 2. Okay, so this is involving recurrence. Okay, many combinatorial problem we have discussed that can be solved using recurrence relation. So one of the famous one is like the Tower of Hanoi problem, and also there are several other problems like suppose in a binary word of length n, if you want to figure out that how many binary words of length n doesn't have two consecutive zeros. So yeah, those can be easily solved using recurrence relation, okay, rather than the usual combinatorial techniques. So yes, I mean, so this is one of such problem where basically you have to like build up the recurrence relation. So Tn denotes the number of ways that can be done. So those who don't know these type of things, that is like what is basically Tn. So I mean, it's not about like a fixed n, it's Tn. So for every n, like for 1 it's T1, for 2 it's T2. Okay, for all the n's that you can, I mean the natural n's, for n the solution would be like Tn. So that's what it's being denoted. Okay. Now it's given that an example T1 is 2, and you can read the problem. So let's not waste time reading it and reading the example. So T2 is 5 and so on. Now the first part says that T2n plus 1 is equals to Tn times Tn minus 1 plus Tn plus 1 for all n greater than 1. So this is what we have to prove. Okay. So yeah, let's go to the whiteboard. So this is the last problem, and then we'll be done posting all the solutions to all the UGB problems. So 2023, this is problem number 5. Okay, so here we have our 1 cross n, whatever. Okay, so this is the first, second, then n and minus 1 and minus 2. Okay, so now first of all, note that Tn minus 1 is equal to 2 times Tn plus Tn minus 1. Okay, so how is that? So now if suppose the first square is covered, like the first square here, it can be either covered by a red tile or a blue tile. Okay, so then the remaining n, so I mean we are talking about sorry, this is Tn plus 1, sorry. So this is our claim. Okay, so we are going to prove this claim first, that is Tn plus 1 is equals to 2 times Tn plus Tn minus 1. Yeah, so there are so this is like 1 cross n plus 1. Okay, so then what we are having here is that n plus 1 such blocks are there. Now the first block, either it can be covered up by a red tile or a blue tile. Then the remaining n squares I mean, we would have to cover the remaining n squares. Now, the first two squares can also be covered by the black tile. So then there would be remaining like n minus 1 tiles or n minus 1 squares to be covered. Okay. And so the first here term is coming out if this is either red. Okay, then the remaining n, so I mean in this case it's n plus 1, so n plus 1. So the remaining n blocks in Tn ways, and if again this is blue, okay, so red and blue are there. So if this is blue, then again Tn ways. So 2Tn. And then if the first 2 is covered by that 1 cross 2 black tile, then the remaining n minus 1 tiles in Tn minus 1 ways. So these are the only possible cases, and thus Tn plus 1 can be filled up in this way. Okay, so this claim has been proved. So I just gave an argument. Okay, so to prove these results, so just arguments are enough. Now, basically, we have to go to T2n plus 1, right? So let's go back to the problem. So we have to finally boil down to T2n plus 1. So now let's consider that is T2n plus 1. Okay, so the last one is like, let's say 2n plus 1, 2n, and so on. So now we are considering 1 cross 2n plus 1. So now for this, there are like odd number of unit squares. So there is something called just the middle one, because suppose if you have like 3 or 5, let's say suppose you have 5, then 1, 2, 3, 4, 5, then you can very well say that so like there should be a middle one, right? So let's say that this is the middle one. 1, 2, 3, 4, 5, 6. Yeah, I have drawn 6. Sorry, that's why. Sorry. 1, 2, 3, 4, and we are done. Yeah. So there are 5, and so this is the middle one. The third one is the middle one. Okay. So yeah, so there is the middle one, and if the middle square, it can be either covered by red or can be covered by blue tile. Okay, so then the remaining, so the middle one, either by red or blue. So when it's covered by red, so what I have n tiles on this side, I have n tiles on this side, because there are total 2n plus 1 tiles. It's not tiles, 1 cross 1 blocks. So then I know that this side, the n blocks can be filled up in Tn ways, and on that side, the right hand side, it can be filled up in Tn ways. So for the red, so when the red one is getting placed, I have like for all each of those Tn ways, I can place the tiles. So each of the Tn ways on this side, on the left hand side, I can go for all the Tn ways on this side. So that means I am basically getting, for when I'm putting the red one here, so I'm basically getting Tn squared. Okay. And again for the blue one, I'm getting similarly Tn squared. So which is basically 2Tn squared. Okay. Now, what could be the other case? That is, I mean, in the middle, but it's not, it shouldn't be exactly middle, but like the black one is sitting, like the 1 cross 2 is sitting. Okay. So in that case, what will happen is that there would be some unequal distribution on both the sides of the I mean the unit blocks. There would be on one side there would be like n minus 1, and on the other side there would be n. Okay, so as you can see, like n plus n minus 1, and the two blocks already covered by the black one. So basically 2n plus 1 tiles. Okay. So there could be two cases, either on one, so on one side we have n minus 1 and n, and again vice versa. So now that like can be done in, so when the left hand side has tn n minus 1, so we can fill it up in tn minus 1 ways. And for each of those tn minus 1 ways, I can fill up this side in tn ways. And just similarly, when there will be n blocks on this side and n minus 1 blocks on this side, so plus tn times tn minus 1. So basically, I'm getting that now I've covered all the cases for t2n plus 1. So t2n plus 1 is nothing but this 2tn squared plus 2tn times tn minus 1. Now remember, we also have proved that tn plus 1 is some this. So we are also going to use that. So now from here we can like take the tn common, because you can very well see like I have to show that this is equals to tn times tn minus 1 plus tn plus 1. Okay. So let's take the tn common. Let's see what we are getting inside. So that is we are basically getting t n minus 1 plus 2tn plus tn minus 1. Okay. Like, okay, let me just show you the calculation part. So like here, if you are just taking the tn common, so what are you getting? 2 times tn, okay, plus 2 times tn minus 1, okay. And that thing I'm just writing it as like because I know that 2tn plus tn minus 1 is tn plus 1, so that's why I'm just dividing and writing it. Okay. So uh, that's why I'm breaking this and writing it as tn minus 1 plus tn minus 1, and this is nothing but tn times, so this I have already proved that this is tn plus 1, and so I have tn minus 1 there, and so we are done with the first part of the problem. Okay. So now let's come to the second part. So the second part, as I said, that it's quite intuitive what we have to do. So here, if you see that we have to prove that tn is nothing but summation d greater than equals to 0 n minus d, choose d 2 to the power n minus 2d. So this term gives you the hint, that is why 2 to the power n minus 2d. So all I know is that the red and the blue tiles, there are two choices for each of the tiles. So that means, and if there are d tiles, d black tiles, so those will cover like two blocks. So that means those will cover 2d blocks. Okay, 2d unit blocks, I mean. And so the remaining will be n minus 2d blocks. And each of them can be filled up in two ways, red or blue. So that's the idea why we should consider d to be the number of black, uh, the black tiles that are being placed, okay, on 1 cross n rectangular plot. Now, how do we come across this? So this is the main question, why this part? So then the question is that now I know that if D black tiles are going to be placed, so now in how many ways? So the very first question comes is that in how many ways they can be placed, okay? So let there be D black tiles of 1 cross 2 that are placed on the 1 cross n rectangular plot. Okay, so D tiles needs to be placed. So now, so those are all the black tiles. So suppose B1, then B2, dot dot dot, and so on. B I minus 1, BI, dot dot dot, BI plus 1, dot dot dot, BD. Now, if they are sitting like this, then I know that there are gaps. Okay. Now, there could be like gaps or maybe no gaps. Okay, whatever. So I know that either these like the consecutive gaps. Okay, so on the last also these gaps length, they are greater than equals to 0 and they are integers. Okay, so because I mean, why integers? Because in those gaps, the units, how many unit squares would be there? That's the count. Okay, there can be 0 unit squares or there can be more than 0, but the count has to be an integer. So we are considering that S1, S2, S3, sorry, so between B2 and B3 it would be S3 basically. So here it would be Si plus 1, dot dot dot. The last one is SD plus 1. So now I'm considering that there are S1 number of unit rectangles here, S2 number of unit rectangles. So between BI minus 1 to BI, there are SI number of unit rectangles. So, and at the end, front, there are S1, and at the end, there are SD plus 1. So now I know that their sum will be what? So the sum of these S1 plus S2 plus dot 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 till SD plus 1 has to be like the number of unit rectangles which are left, that is the total number where was n minus 2d. Okay, so now this is the main equation that we have to solve. Now we know that like since all these SI's are greater than equals to 0, and then so we have to basically solve this equation 1 for non-negative integer solutions. Okay, because the gaps could also be like having 0 number of unit squares. So the number of non-negative integer solutions to this equation is nothing but n minus 2d. So the idea is to break this n minus 2d into n minus 2d once, and I'll be using to separate these d plus 1 variables. I need d plus 1 minus 1, that is d boundaries. So for those boundaries, I'll be taking zeros. So it's basically the number of binary words I can make with all those ones and zeros. So n plus 2d plus d plus 1 minus 1. So I have these many ones and zeros factorial divided by n minus 2d factorial and d factorial. So this is nothing but this is n minus 2d. Choose D. And now I can place those D black tiles in these many ways. And each time I place them, the remaining places, that is the remaining n minus 2D places, can be filled up in 2 ways, either red or black. So times 2 to the power n minus 2d. And since like there could be 0 black tiles, there could be 1 black tile, and so on, so d is greater than equals to 0. And as according to the definition given that of this m choose r, so if d is basically becoming larger than r is becoming larger than m, so the rest becomes basically 0. Okay, so yeah, so that's the thing, and we have like proved the part B as well, and with this we have proved all the problems in this from this UGB 2023, and yeah, I have also like solved the objective ones, but and I'll be going to post the solutions as well to them. So yeah, I'm currently typing them out. So I'll just post them on the website, and I'll announce it on the channel as I posted. But I started posting the subjective problems because those are the ones where many fail to prove the whole matter perfectly. So that's why I started with the subjective questions. The MCQ problems you can still like, it's just which option is correct. So you can just even go for it without actually like going through the whole proof. So here you have to show the whole thing. Okay. So that's the difficulty. So yeah, with this we are done with the UGB part. So if you have watched all the videos, and I think if the solutions have helped you in any way, so please don't forget to put a like. So thanks for watching. Keep watching and keep learning, and see you in the next one.